Hi, this is Mike Sayers from Mechanical Simulation. This video is part one of an introduction to CarSim, giving an overview of the software. And although we talk about CarSim in it, the basic operations also apply for our products TruckSim and BikeSim. CarSim is a software tool for simulating the dynamic behavior of passenger vehicles and light-duty trucks. It uses a 3D multi-body dynamics model to accurately reproduce the physics of the vehicle in response to controls from the driver. These would be steering, throttle, braking, gear shifting. Environmental conditions include a 3D ground road surface, as well as aerodynamic and wind effects. The modeling and simulation technology in CarSim is from something we call Vehicle Sim, which you often abbreviate as VS when we're referring to other parts of it, like the VS Browser or the VS Visualizer. This is VS Visualizer showing video of a run and also synchronized plotting. In this case, it's got overlays of two runs, one with ESC and one without, and we see the plots that show the difference between the two. The math models in CarSim were originally developed for mechanical engineers in the auto industry and in research labs. The intent is to reproduce results that are obtained in proving grounds or on the highways with the same agreement as you get from test to test repeatability. The CarSim math models are represented at the system level. That means that the vehicle data is intended to be either measured or calculated and does not depend on detailed knowledge of component materials. What we're trying to do is make sure that the simulated vehicle responds the same way to driver controls as is measured. CarSim uses a combination of parameters and variables to represent the vehicle. As shown in the screen here, we have dimensions that are measurable for the vehicle, our parameters. We also have tables that represent measurable properties such as suspension kinematics. We have camber versus jounce. These are outputs that you get from K&C rigs, or detailed suspension models in programs like Suspension Sim or Adams. The same approach is taken with tire data, where we're getting the data that comes from tire rigs to come up with longitudinal lateral forces and lining moments versus vertical load, longitudinal slip, and lateral slip. These go into a variety of tire models that we have available. We also use parameters and tables to represent parts of the powertrain. Here is an engine map giving engine torque as a function of speed and throttle. We have this as part of a internal combustion powertrain that is rear-wheel drive. We have front-wheel drive. We have all-wheel drive. In each of these specifications of which wheels are powered, we have the options of it being internal combustion, hybrid, or all-electric. This is our hybrid screen where we manage the control between the engine, the battery, and a planetary gear that distributes torque to the wheels. In the last few years, there's been great interest in simulating scenarios involving advanced driving assistance systems, or ADAS. In this one, the blue sedan with the yellow arrows on the sides are the ego vehicle. All the other traffic vehicles are represented as moving objects in CarSim that can have basic physics controlling their motions. CarSim comes with a database that has hundreds of simulations. Every guy on this menu is a simulation that has already been run. We have about 40 vehicle datasets in here that are based on about 10 unique vehicle configurations. CarSim has extensive documentation, that's the help menu, and every screen has a help button. There are about 140 documents. To install CarSim for Windows, you'll get the installer downloaded from our website and run through the steps like most installers. You'll be asked for two path names, one for the program files and one for the database files. It will extract them. It takes a little longer. We speeded this up for you. And when it's done, you'll have now in your Windows directory with program files one that is called CarSim Prog, and that's typically a read-only part of your operating system. You might even have write access to it. That's okay. The other one is CarSim Data. That is our entire database, and you can copy it, you can rename it, you can have multiple databases on your drive, and if you want to go back to the original, you can always install the database alone. Well, you've seen bits and pieces of results shown with VS visualizers, and you've seen screens that we use to set up the data. We'll take a look now at basically how you set up runs and make them. This from documentation is showing the main GUI screen in the CarSim browser, the database browser. On the left side of the screen are controls that we use to set up the simulated vehicle and test maneuver. In the middle of the screen are controls to run the test, and on the right hand side are controls that let us view results and view more information about the model as we've set it up. We'll go to the real screen and look at the list in the lower right hand corner that identifies the number of files that are generated with every run we make. The echo file tells almost everything there is to know about the conditions used in a run. It has the title, of course. Every single parameter is listed along with the value, organized in sections, so we have system stuff at the top, and then top level vehicle things, and then components like the suspensions and so on. And after that we have tables, so every table that was used in the model is listed in here. Now the GUI in CarSim has controls that you're used to, like checkboxes that hide and show options and drop down controls that give you multiple choices. We also have these blue rectangular things with text in them, and you notice when I put the cursor over it, it underlines it like you would see in a web browser for a hyperlink. In fact, that's what these are. This is a hyperlink that takes me to another page in another library. This is the vehicle page. It has more hyperlinks in here. I click the one for the sprung mass, which we've seen before, and these are parameters for the sprung mass. Now, unlike a remote website, they use HTML, we're using something much simpler in here. We have our parameter files that we call Parsfiles. They're just text, and it has a keyword and then a number. This is the same format that we saw in the echo file, and this is how we maintain our data in here. I have a parameter out here that's 1405. Right here is 1405. So now we'll go back to the home screen, and to make a simulation we just click the button up here that says Run Math Model. By the way, if there's any ever doubt about what a button does, you can right click on it and it gives you instant documentation on that. I run the model, it goes very quickly. We'll click the Video plus Plot button to view the results. It's like we have seen before. There's a video view on one side and plots on the other side. We can go very quickly to view any one of these plots in the grid by double clicking on it or typing Z. We can see values of the variable by typing V, and we notice that they're synchronized, so that wherever I put the cursor down here on the timeline, I see the image of where the vehicle is over here, and I see what the corresponding values are on the plot over there. With our we can move our virtual camera around to zoom in and out. We can go backwards and forward, go to any place that we want. We can go to the max and min values for any of the plots. So we've seen some of this before. It's a very quick way to analyze things. There's also an echo file that's made at the end. We'll view that, and this is very similar to the echo file we had at the beginning, but there is another parameter in here. It's R time. This is the computational efficiency. It's saying that when we ran this simulation, for every 1 second of simulation time, it took 0.06 seconds of clock time. So that's like 15 times faster than real time. And then we have a lot of information at the end involving state variables and parts that are in the model that advanced users might want to look at. Now that you've seen the basics of using CarSim, we'll conclude this video. But come on back, there's some more in part 2 where we show some advanced features.